The level of a measurement is what kind of value can be assigned. Level of measurement affects the use to which we can put the measurement. The four categories are nominal, ordinal, interval, and ratio. Nominal variables are names, which is what nominal means. A nominal variable can be green, up, left. There is no better or worse ranking, just names. Ordinal variables are nominal variables with a ranking scale, like good to bad. An ordinal variable measured on pies could be tastes good, no taste, tastes bad. The ranking shows a preference. But there is no implication about how much more or less one variable is than another. The preference can also differ among individuals. Scores for gymnastics or skating events are ordinal, even though they are expressed in numbers. A mistake may cost a 10th point deduction, but judges may differ on the definition of a mistake. Judges assigning different scores for the same performance shows the ordinal nature of the scoring. Interval variables have a number scale with meaningful differences between values. The best example of interval variables is temperature scales. Fahrenheits have the same 5-degree difference between 20 degrees and 25 degrees as between 30 and 35 degrees. That's what makes Fahrenheit an interval scale. The Celsius temperature scale works the same way. The interval difference between 20 and 25 is the same as between 30 and 35. But 20 degrees Fahrenheit and 20 degrees centigrade are very different. The scales have equal intervals internally, but have different beginnings. Water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The Celsius scale counterparts are 0 degrees centigrade and 100 degrees. Many other temperature scales have been used in the past. All are internally consistent, but have different intervals between them. For example, the famous graph of Napoleon's retreat from Moscow uses the Raymer scale. Ratio variables are interval variables with a natural zero. Real whole numbers, -3, -2, 1, 0, 1, 2, 3, have a fixed point that ties it down. Unlike Fahrenheit and Celsius that slide around, real numbers have equal intervals and a fixed zero. The interval between values in a ratio scale may be different, like feet and meters, but both scales have the same zero. We can only calculate statistics like the mean and standard deviation for interval and ratio scale values. For example, there can be no average color among red, blue, and green, but we can average 5, 7, and 10. Problems arise when statistics are calculated for nominal or ordinal scales. One common example is using statistics for Likert scales. Everyone has seen a Likert scale example. Preferences or satisfaction are described by categories that have a value attached. A Likert scale ranks preferences such as agreement with 1. Strongly disagree, 2. Disagree, 3. Undecided, 4. Agree, and 5. Strongly agree. The difference between any of the 5 categories is not consistent. I may have a very different criteria for strongly agree than someone else. Why is strongly agree only worth a score of 5? Why not a 10? Averaging the results is like averaging how people feel about apple pie. There are many other examples of misuse of statistics and level of measurement that are not so obvious. Some examples are a deliberate attempt to deceive. Most often, these are included in deceptive graphs.